15. All right, number 15 is definitely one that you'd want to do Desmos on. Am I on the wrong page? It says find all the zeros, that one. The x to the third, this one down here. All right, so jump on Desmos with that. So when it says it's trying to find the solutions, you're looking where it crosses the x-axis. Bold there. And change h at x to just y equals, you have x raised to the third plus x raised to the second minus 4x plus 6. All right. So it says find all the zeros. Okay, so that's definitely a 0 right there. Okay, now here's the trouble. You see the graph, how it kind of, to the right of that, changes directions and heads back up? What that basically means is you have two non-real solutions that take place at this juncture. It's not coming down to the x-axis. So this is a real solution. There's going to be two solutions that aren't real. Okay, so I'm going to take that -3 and I'm going to use synthetic, I'm going to use synthetic division on it. So I have x to the third plus x squared minus 4x plus 6. And Desmos showed us that -3. -3 works. Okay. So -3 comma 0 is, this is a real solution. Okay. So what it means is we need to try and figure out what the two imaginary solutions would be, or the two complex solutions would be. So first thing you're going to do is you're going to use synthetic division on this. I know there's ones there. Bring this down. So that's -3. Bring this down. So that's -2. That's 6. Bring this down. That's going to give me 2. And then 2 times -3 is -6. There's a 0 there. Okay. So this is important for us to see this. Okay. So what I did in pink, so originally it was x to the third. I divided one dimension lower, which means this is x squared. Okay. And there's really a few ways that you would have information. This means that that's x squared minus 2x plus 2. Okay, this is not going to factor. This is not, if we were to graph that, it's going to be a parabola that happens above the x-axis, okay, like we had seen. So the only other way to get through this problem is you're going to have to use our best favorite equation. And if you remember the song, it might be going through your head right about now, and I'm sorry about that. So we know that our A value is 1, our B value is -2, and our C value is 2. So x equals -b, so it's -2 plus or minus -2 quantity squared, which is 4, minus 4 times our A value times our C value, all divided by 2a. So x equals 2 plus or minus, this is going to give me -8, so I'm going to get a -4 down here over 2. Square root of 4 is 2, and you might have heard of complex solutions at some point. This is going to come out to 2 plus or minus 2i over 2. The I came from because I took the square root of a negative, okay? And then everything's a 2 here, which everything reduces. So my other two solutions to this problem are 1 plus I. Now, I have to ask you this. Have you seen imaginary before? I'm not sure. Has anyone not seen imaginary before? You're kind of like, wait, where's this imaginary stuff coming from? Okay, so imaginary numbers take place to take care of an undefined term that we knew in the real number system, which was a square root of a negative number. Okay, so our solutions to this problem are -3 and 1 plus I, 1 plus or minus I. That should be a plus or minus I. I'm sorry, forgot the minus there. Okay, 1 plus I and 1 minus I. Those are two solutions. They stand for the complex numbers. They do indeed exist. Mathematicians had to create a way to come up with another number system just to mess with society. And that's basically what it comes to. Nice thing is, I didn't put that on the quiz. Any other questions other than those last 4 on there? Good? Happy? Now let's take care of those last 4. All right, so it says we want to find the domain. Well, if I'm going to find the domain, I'm going to use Desmos to allow us to find that. So I'm going to get y equals, and I have to find the square root button, which is this. And I'm going to go x minus 4 in the denominator. Okay? So, things that we have to establish. This point right here is on the x-axis. This -4 does indeed exist because if I take -4 and I plug it into the original equation, 4 minus 4 is 0. Square root of 0 is indeed 0, so it does exist. Okay? That's the first thing to know. Now, if I want to, I'm going to annotate on top of here. Okay, so our domain. Okay, it's going to start from 4 and it's going to go forever to the right. So I can never get to infinity, so that's a soft bracket. But because because 4 works, meaning it gives us a real answer, you put a square bracket there. So if you plug values from 4 and greater in, you're going to get real number solutions. They will be both rational and irrational. And if you remember, irrational values are things that are decimals that do not have a repeating pattern. So that's that first problem. Good enough there? May I move on? All right, I'm going to erase that real quick because I don't need that any longer. And let's try the next one. I believe that says third root of x. Agreed? So I have y equals, we want the third root of x. Okay. So maybe we have to search for the actual third root. There might be one. If not, we have another way to do it. Yep. So you search for it under functions. You find the nth root. So we want the third root of x. And this is like s that goes forever. This gray dot here is just saying, hey, it's just crossing the x-axis at 0, 0. But this graph goes forever left, forever right. So the domain of this is going to go from negative to positive infinity. Okay, everything's going to work. Okay. Questions there? Are we good? Then I have ye 3 over x minus 8. 3 over x minus 8. This is going to kind of look like a obscure looking item. Okay. So as I'm traveling along, I go shooting straight down. And then all of a sudden I come, it's like I went down forever, so I actually started off on top. It's not really how it works, but theoretically. And then it comes out from here. So we have to think about this is called a vertical asymptote. This vertical asymptote is taking place at 8. The reason it's taking place at 8 is if I plug 8 into the denominator, I get 3 divided by 8 minus 8, or 3 divided by 0. When you have a 0 underneath on a fraction, it becomes undefined. So this is an asymptote, and I want to just show you that this is what this asymptote looks like. That purple is the asymptote there. Okay? So you're getting very, very, very close to it. When, have any of you taken pre-calc yet? Any pre-calculators in here? This is actually a problem that you will see in the future. It talks about limits. This limit does not exist because that purple line goes both directions. Okay? But don't worry about knowing that now. So I'm going to go for my domain, I'm going to go from negative infinity to 8. And then I'm going to go from 8 to infinity. And the 8s have a soft bracket because you get really close to it. You never touch it. And that's what the domain is. So this part is this part of the graph. And this one is this part of the graph. Okay, so it's basically a value that creates an undefined term by dividing by 0. That's how you deal with that problem. So negative 8, or negative infinity to 8, soft bracket on the 8, 8 to infinity. So that just basically means that this 8 does not work in this problem. Okay? Good so far? Then we have square root of x squared, y equals the square root of x squared minus 16. So this is what this graph looks like. I'm going to come click on the x-axis. I need to verify that those points do indeed work on my graph. If I take -4, plug it in, -4 quantity squared becomes 16. 16 minus 16 is 0. Square root of 0 is 0. That works. If I take the 4 and plug it in, 4 squared is 16. 16 minus 16 is also 0. Square root of 0 also works. So the domain of this one is going to go from negative infinity to -4, and it's going to be a square bracket on the 4, and then I'm going to start at 4, and I'm going to go to infinity. So that just means this whole region in between here, the graph does not exist. It's just not going to happen. So that's what your domain on this particular one is. You go negative infinity to -4, hard bracket on the -4 because it is a dot that will work as part of the equation, and then goes from square bracket 4 to infinity in order to get there. It's kind of a wild looking graph. Maybe the first time you've seen it, unless you accidentally plug something in like that on a calculator. And then letter E, and do y equals 2 over x squared minus 9. Look at that hot mess. Oh. Start from mortuary, you establish level. Damn it. Please continue. Sorry about that. They want me to donate blood. Did I answer it as a mortuary? All right. So for this particular problem, let's clear all of the ink. Okay. So what are the values that would make the denominator 0? Meaning, what can I plug in for x that I square it and I subtract 9? 3. Yeah. What's the other one? Is -3 times -3 also 9? So this one actually has two vertical asymptotes, and your vertical asymptotes are x equals 3 and x equals -3. So those are the asymptotes. So what's basically happening here is this left part of the graph is approaching -3, and then the graph is going to exist between -3 and +3, and then from +3 it's going to go on to infinity. So this has three locations for our domain. Our domain of this one is going to go from -infinity to -3. The middle is going to go from -3 to 3. And then it's going to go from 3 to infinity. So that domain has three parts where the graph exists, meaning that the only two places it can't exist are at positive and -3. And that, my friends, is how you do that. All right. So for tomorrow, which was Tuesday, let's take a look at, we'll call it the algebra review. Okay. I would say, bless you. We don't need to worry too much about these. So skip 1 through 10. And then look at 11 through 16 there. Take a look at 17. And looks like all the rest would be easy enough to do. So I'll give you the rest of the period to work on, starting on number 11 and 11 to the rest of it, okay? If you need help, I'm happy to help.